to the text box a link, and there's a username and a password. So as you follow the presentation, you can actually go to prompts and see the results yourself. I run them on PowerPoint, but these are actually direct screenshots from the prompts. So do you see the presentation?
Yes.
All right. So we talk about online forest fire and biodiversity management tools for handling cross-border fires. And here's the funders and participants of this project. It's a CBC funded project. And here is the link that you can also see in the chat box. So feel free to play with it during the presentation and after. So first, we will look at the canopy fuel connections over the Finnish and Russian border. So we will, in this presentation, we'll look two kind of connections that are related to fire management. One is the canopy fuel, and another is the high flammability sites. So there's basically two kinds of transit of fire. One is if you have a canopy fire, it's a direct transit to the neighboring stands. Well, of course, the surface fires can also connect, but then this high flammability sites will also present a possibility of spotting. So when the fire is burning, it sends sparks and burning particles that can make new fires downwind. So here is the target area of the project, and we are actually looking this now in the prompts environment, and you can see that we have a Sentinel satellite image mosaic made to cover this area. So in the analysis we actually used actually four different image sets. There's this Sentinel red, green, blue from spring, which is before the leaf on. So it's a snow off, leaf off image. And then we have color infrared Sentinel 2 from the same, and red, green, blue image from summer leaf on, and color infrared from leaf on as well. Actually, if you look in more detail, the Sentinel has more bands, and all the Sentinel spectral bands were included in the analysis, but this just gives you a little view to the data. And you can see the Finnish-Russian border, and you can see our project target area also. So when we start to do this analysis, we were kind of lucky by having Arbonaut having analyzed the forest fire management layers for Lieksa area already. So these are done from LiDAR, and LiDAR is a laser scanning data of the target, and it has a special capability of mapping the 3D structure of the fuels, and it also has a very high accuracy on measuring some of these fuel parameters. So here you can see the little black dots on the Lieksa area. They present our training data for the satellite. Satellite is good at covering wide areas, and today satellite data is readily available in different platforms, and it has a good coverage. The downside is that because it's spectral data and passive data, it does not provide such a good information on the vertical features of the land. It's more like the color appearance on the current illumination conditions when the image was shot. But here's our training set for the canopy fuel weight. I also here mention a little bit about the canopy fuel weight. So there's two kinds of measuring the fuels on the canopy. There's canopy fuel weight, CFW, and then there's the canopy fuel density. So canopy fuel weight is given either kilograms per square meter or tons per hectare. And then the canopy fuel density considers the airspace inside the canopy and sees how much kilograms per cubic meter of airspace is their fuel. And we decided in this project to work on the canopy fuel weight because it's easier to analyze from satellite imagery, and it gives also good idea of the fuel connectivity on the border area. So here, this is just a zoomed in piece where we can see some of the training data in detail. So we are zooming into this Lieksa area where you see these little black scatters in one of the areas, and here you can see a few sample locations. So when you have a full coverage LiDAR data in the training area, it's very convenient to do sampling because you can just put any kind of random sample or some organized sample into the area and ask from the LiDAR data that what are the properties here. And here actually, when you look at the canopy fuel weight on the scale on the right hand side, we have divided into 10 classes that are represented by color. So we used like automatic classifier to identify the amount of fuel. So this is not like a continuous model, but rather a classification approach. I think this gives a good idea of the fuel connections. And as you see here, we are looking about a dozen training plots, if you will, that were made using the LiDAR data from there. And now we here is the analyzed result. So we have taken this satellite imagery and fed it the training data and analyzed the quantity of the canopy fuel in this training area. So I'll flip-flop this a little bit so you can see how it works out. So you can see that there's quite a lot of the classes 7 and 6, but then you can see some areas with classes 8, 9, and 10 that have more fuel in it. And now, when we have made this model that can analyze the area, we feed the entire satellite dataset into the model. And poof, I did not zoom to the entire area, just because then it looks like a bit shady, same color all over. But with this scale, we can see the Karhukolmio area that Yevgeny mentioned on the lower area here, and then you can see some of the Kuhmo border area and the canopy fuel map. You can actually see this funny checkerboard pattern that's characterized by the Russian logging practice. So square-shaped cuttings are done. And then you can see some of the areas. This is a protected area, and this was the Karhukolmio area that Yevgeny mentioned that's not yet protected. You can see in Finnish side also some of the protected areas and with high amount of canopy fuel. The scale bar, by the way, is here. This gives you an idea of what scale we are looking. And now we are zooming into this area. I chose this area just because it seems to have some interesting connections over the border. So here we are seeing the Finnish border, and then we are seeing the fuel on both sides. So I think this data is helpful for the fire management officers on both sides of the border. If they see that there's a fire in one area, they can immediately investigate that, okay, is there a canopy fuel connection? So if we get the canopy fire, what are the avenues and even probabilities that this fire could run as a devastating canopy fire to the another side of the border? So this is, I think, quite practical connectivity analysis. We can, for example, here on the north see that in Finnish side there's a protected land with quite a lot of fuel, but in Russian side it's harvested mostly, which means that this makes a fuel break that probably hinders the fire from entering. If we had a fire on this area here, in Russian side, we could see that, okay, now we have a direct fuel connection, even if the fuel load is lower in Finnish side, but there's a significant fuel load on both sides of the border here. So this is how you can use this kind of data. Well, this is the historical fires by type on Russian side. Unfortunately, I don't yet have the Finnish fire history data. We will be getting it later on, but I think this gives an idea of how the historical fires can be also added to the data. So the historical fires are categorized here by the intensity, type and intensity. So most interesting fires in terms of risk are this bright orange running crowning fire. These are the ones that spread with very high speed in good wind conditions and can be devastating and cross the border real quick. And then the lower intensity fires are presented here with black and gray and white scales. So this gives you idea where historically fires have occurred close to Finnish border. We will have the corresponding data set on the Finnish side as well. Here we are looking, I was zooming actually, let's go to this area where we see lots of fires close to the border. And actually when we look at these fires a bit more, we can see that there's quite a few of them are actually caused by native reasons, storms or lightning, but there are some red anthropogenic fires that are caused by humans. Normally, if you have land that's occupied heavily by humans, you'll see that there's lots of anthropogenic fires, and then some wildland areas where the fire detection is slow, then you will see wider areas burned by natural causes. So here we are looking at this inset. So we have actually some of the orange crowning fires here happening, and when we look at the scale bar, they are, for example, this fire is closer than 5 kilometers from the Finnish border. So this would be something that the Finnish fire management officials should be quite interested in, if this kind of information comes that, okay, we have a crown fire here. There's a high probability, if the wind happens to be suitable, that it comes to the Finnish side. The brown fires also, if I go back here, we can see that it's high intensity running ground fire. So this fire type also has quite fast expansion, but it's not even close to what the crowning fire. We also have here some smaller fires that are very close, but in this case, for example, the lake has been protecting and so on. There is one fire that's very close to the border. Now we look another feature of the fuel connection. So we are looking the ignition sensitivity map, and if we characterize the ignition sensitivity, it's actually funny that the high canopy fuel areas are not necessarily the most sensitive for ignition. So we are looking the ignition sensitivity in a. You could imagine that if I take a match on the dry fire season and drop it to the ground, so you could kind of imagine what's the percentage that you will start a fire. And this is not exact definition of the ignition sensitivity, but you can kind of consider it in this kind of practical term. So when we look at these ignition sensitivities, the color indicates the sensitivity. So the highest are about 50% chance if you drop your match on random location there, it will start a fire. That's a high, very high ignition sensitivity. And our training data again is from the same area here as the another. So this is Lieksa area. Yeah, I wanted to say a bit more about the ignition sensitivity. In typically the most sensitive for ignition are actually clear cuts after a few years of harvesting, when they have still high amount of tops and wood there left. and the grass has grown up. And when it turns yellow, you can imagine this yellow, grassy, dry, clear cut. And when you put the match on it, you're gonna have a fire, quite probably. So let's see. Here we used actually polygons, the Finnish open forest data polygons, where we have this ignition sensitivity defined using LiDAR and the forestry data together. So you can see some of these training polygons here. And now this is the analyzed result when the satellite model is done. The model is done to predict in the satellite. So you can see the red areas are the areas with very high ignition sensitivity. And then there are the lighter areas, the green are very low, it's difficult to burn them. And white areas are probably so wet or so low that you don't expect any ignition. And then there are some areas that are yellowish or orange colors that are like average level. So let's look at the ignition sensitive over the border. So we can see that there are areas, for example, here in Russian side where you have pretty lots of harvesting. You can see these areas are more red, and here you can see some individual areas that are showing high sensitivity for ignition. And now we go zoom in a bit closer, so we can see this border area, and as we have seen in many other aspects, in Russia the figures are bigger in terms of area, and Finland is more scattered in terms of forest type. But both sides have high ignition sensitivity areas. So now if you have a forest fire, no matter if it's a ground fire or surface fire or ground fire, it produces sparks and burning material that the heat created by fire raises up in the air, and then they fly and land somewhere. And there's actually quite good models existing that how does the spotting work, how much new fires you're gonna expect in what distance when you have a spotting fire. So if you look at this, these ignition high sensitivity areas are the ones that would easiest start the spotting fire. Then this fire can, okay, thank you. So then this fire can continue spreading, and maybe it catches a fire ladder that vertically raises it to the canopies in the next stand if the structure is suitable for that. And that's how the ground fire normally is started, unless it's made originally to the ground by storm. And here we are looking again some area near the border where there's been fires, and where we can and now we have behind the ignition sensitivity data. So it's all about wind now, and all about the suitable fuels to start a fire. And in the end, I just took a photo. This is actually from Finnish border troops Twitter page, but I think it fit to this case. So here's the border zone, and then there's a fire, and some people are there putting down, protecting the fire from spreading to another side of the border. So I think this kind of activity may be needed if this kind of border crossing fire happens to be appearing. Thank you, everybody, and any questions, please?
Thank you, Vesa.